This video is for section 5.5. Our objective in this section is to factor the difference of two squares. So we're going to talk a little bit about where this process comes from. And if you think about FOILing something where you have the same thing, but you have one with a plus sign in the middle and one with a minus sign in the middle. Now what's going to happen when I FOIL this is I'm going to get a squared for first. For the outside, I'm going to get minus ab. For the inside, I'm going to get plus ab. And then for the last term, it's going to be positive b times negative b minus b squared. So what's going to happen here is that the middle two terms are going to cancel out. And I'm just going to be left with a squared minus b squared. So what we're going to do is we're going to use this now in reverse. We're going to have something that looks like a squared minus b squared. So it's going to have two terms. Both of them are going to be perfect squares, and there's going to be a minus sign in the middle. That's why it's called difference of squares. We're going to factor that into two sets of parentheses, where the terms in the parentheses, when you square them, you get what you have in your problem. So for coefficients and constants, if we have a number that's in the form a squared and we want to find a, we take the square root. For exponents, we're going to divide exponents by 2 on variables. So this is the formula that we're going to be using. So let's take a look at example 1. There's two problems here. And what you notice in these difference of square problems is that the numbers in the problem should be perfect squares. So we have 9, we have 100, we have 36, we have 49. I know that those numbers are the result of squaring other numbers. And then there's always going to be a minus sign in the middle. If it were a plus sign in between the two terms, then you can't use this. It only works if there's a minus sign. So what I'm going to do here, so I'm going to have two sets of parentheses, and then what I have in my problem is this is a squared and this is b squared. So if a squared is 9x squared, then a would have to be 3x, because when I square 3x, I get 9x squared. So the a here is 3x. I'm going to have one plus sign and one minus sign in the parentheses. If b squared is 100, the number that I square to get 100 is 10. So there's going to be 10 here for b. So this is a plus b, a minus b. So my answer here is 3x plus 10 times 3x minus 10. Now, if I check this using FOILing, I should get back to what I originally had. So if I do FOIL on this, I'm going to get 9x squared for first, minus 30x for outside, plus 30x for inside, and then minus 100. So what you notice is that the middle two terms, minus 30x and plus 30x, those should always cancel out, and then I have 9x squared minus 100 left. So that's what I started with, so it checks out. Looking at problem B, it's the same thing. What I'm going to do is I'm going to just kind of go through from left to right. So I know that the square root of 36 is 6. And for y to the 6th, now for exponents, I'm dividing them by 2. So 6 divided by 2 is 3, so this is going to be 6y to the 3rd. Now I'm going to have a plus sign. My second term, square root of 49 is 7. And then divide exponents by 2, that's going to be x to the 2nd. 4 divided by 2 is 2. So that's one set of parentheses. Now I'm just going to copy that again to get my second set of parentheses, except change the sign in the middle to a minus sign. So that's the answer. And again, I can check this using FOIL. I get 36y to the 6th. Remember, when you're multiplying, you're adding exponents, so y to the 3rd times y to the 3rd is y to the 6th. For outside, it's going to be minus 42x squared y to the 3rd. Inside is going to be plus 42x squared y to the 3rd. And last is going to be minus 49x to the 4th. So again, middle two terms cancel out. We have 36y to the 6th minus 49x to the 4th, which is exactly what we started with in the problem, so it checks out. So next you should do the problems from checkpoint number 1. Do these in your notes, check your answers, and then you can move on with the rest of the video. So next we're going to look at example 2. You see in this one we have 3's, which are not numbers that are perfect squares. This problem, what I need to do is factor out a GCF first. So if you see something where it has two terms, it has a minus sign in the middle, but you know the numbers aren't perfect squares, then what you want to do is look for a GCF that you can factor out, and that will give you something that then you can factor using difference of squares. So in this case, my GCF is going to be 3y, and then that's going to leave me with 1 minus x to the 6th, y to the 4th. So now, this set of parentheses I can factor using difference of squares. So it's going to be square root of 1, which is 1, plus divide exponents by 2. I get x to the 3rd y squared, and then copy that same thing over, just change the sign in the middle to a minus sign. And then lastly, what I need to do is put the GCF on the outside. So a lot of times when people get these problems wrong, the mistake that they're making is that they forget about that GCF once they take it out. It doesn't go away, you just need to stick it on the outside of that first set of parentheses for your answer. So this would be the answer for this problem. So next you should do checkpoint problem number 2. It's quite similar. Do this in your notes, and then you can move on with the last example in the video. The last one that we're going to do here is example 3. It says to factor completely, and that's kind of a clue that there's going to be multiple steps here. So we see, looking at this, my numbers are 81 and 16. I don't have any GCF that I can take out that's in common between both of those, and there's no variables to take out either. So we can go right to factoring difference of squares. I know 81 and 16 are both perfect squares. Square root of 81 is 9. And then divide exponents by 2, that's x squared. Square root of 16 is 4. And then copy the same thing over again, just put a minus sign in. So from this point, it's pretty much the same as the problems we've already done. However, what happens here is that I get one term that is itself a difference of squares, so it can be factored again. This term with the plus sign can't be factored anymore. There's no GCF, it's not a difference of squares because it has a plus sign in the middle. However, when I look at 9x squared minus 4, that is itself a difference of squares because 9 and 4 are perfect squares, it has a minus sign in the middle. So this one can be factored more. So the term that can't be factored anymore, I'm just going to bring that down. 9x squared plus 4. And now I'm going to factor the second set of parentheses. So square root of 9 is 3. That's going to be 3x. You can also do dividing exponents by 2 is squared because 2 divided by 2 is 1. So this is x to the first. And then plus 2, square root of 4 is 2. My second set of parentheses for that is going to be 3x minus 2. So this term, the 9x squared minus 4, factors into these two. And then I have the one that can't be factored. Over here, I just bring that down. So this would be the answer for that problem. So what you should do next is checkpoint problem number 3. Do this in your notes, check your answer, and then you can move on to the homework.